faculty and we are studying chemical engineering. This presentation is about a study of the impact of particle size and absorption phenomena, all this in a compost-based in a biogical. First of all, we have an abstract, and I would like to tell you that this article is a clear example of an application that we have seen in class. Well, this says that the removal of toluene by biofiltration has been investigated. This article has two objectives. The first one was the study of the impact filter bed pellet sizes. These pellet sizes are 3, 5, 10, and 20 diameter on the biodegradation performance. And the second one was the determination of absorption isotherm for toluene on the bed filter. Other point that have the abstract was that the 3 different pellet sizes were evaluated with an airflow rate of 1 cubic meter per hour. And well, it was shown that the pellet size and a specific surface area were limiting with the factors for biodegradation process. And we have the result that for the optimal concentration, that was 2 or 3 grams, the maximum elimination capacity is decreasing with the pellet sizes, but increasing with the specific surface area. We have an introduction when the author says that the biocatalytic oxidation of pollutants is performed by microorganisms immobilizing within the fixed beds of the bioreactors. Other important point is that the success of the overall biodegradation process is totally inherent to the microbial activity. About the sizing of the bed pellets, says that if it's too small, this provides for large specific surface area, but if it's too large, it favors gaseous flows but reduces the number of potential sites for the microbial activity. And a few studies actually deal with the impact of the pellet sizes on pollutants removal.
Continuing with the second part of the experiment. This is the experimental setup. As my classmates say, it was performed in 3 identical laboratory scale filters, small, medium, and large. And each biofilter was filled up with a set of pellets of diameters of 5 millimeters, 10 millimeters, and 20 millimeters, the size medium and large pellet. In the third part, they say that each biofilter section was provided with a stainless steel mesh. And in the fourth, the air provided by the compressor was artificially polluted with oven. Okay, in the fifth part of the experimental setup, they say the airflows were regulated by mass flow controllers, and the connection between the components were made from Teflon. Then the gas sampling ports were installed along the bioreactors for pollutant level analysis. And in the last part, the additional ports were provided at the midpoint of each module of temperature monitoring. This I'm going to explain it in the next. We'll continue with the experimental part. Here we have the experimental setup for the particle size study. First of all, we have the air compression with the airflow mile rate. The airflow is divided into two sections. Here, the air passes through a screw chamber that has a little bit of swelling. Then, another part of the air passes through the mass flow controllers to the modification tower, and these two regions join together in a mixer. Then in the mixer, they pass to this tower that has 3 modules. Each module is for every size of pellets with a pressure drops, a gas sampling to hydrocarbon and CO2 analyzers. And as I said in the last part, the temperature was controlled with bed sampling for microbial analysis. Well, this is a irrigation part. They say that each biofilter were irrigated with 1,3,1 solution per day. Then the system was composed of a centrifugal pump and connected to the tank that contained the nutrient solution. This is like the diagram we have seen. That the nutrient solution was made from a saline solution with macro and micro elements, such as these compounds in this kind of elements, and the nitrogen was provided separately in various amounts. Well, this is like the experimental protocol. All the parameters and the settings they put to made of the experiment. The filtering material, a compost organic blender, the pellet diameters, small, medium, and large, porosity of the wet medium, density. These are all the considerations for operating conditions in the biofilters. Well, they said that in the experiment the nitrogen concentration increased from 0 to 7 grams of nitrogen. They discovered that in biofiltration performance the content of nitrogen is important because this leads to the existence of several distinct degradation zones, this depending on the nitrogen load. And this is important that for each N concentration applied, the steady state condition was established before effecting further changes to the nitrogen input. Well, here we have the table 2, that is the nitrogen concentrations applied to each biofilter. Here we have the different biofilters, the small, the medium, and large, with different nitrogen concentrations. In small biofilters, they had that the nitrogen concentration up to 0, up to 8, I think, or 7. And this was the days of the corresponding operation periods. In medium biofilters, they have N concentration equal to this, to 0 to 7. And here they have the days of operation to 92 to 98 days of operations. And in large biofilters, the N concentration was to 0 to 6. And they discovered that the days of operation were much less, up to 23 to 34 days. Well, the performance of each biofilter was compared mainly with these two equations, the elimination capacity and the production of CO2. The elimination capacity is the concentration of inlet and outlet concentration of toluene, the flow rate divided into the bed volume, and the production of CO2 was the concentration of inlet and outlet of CO2. Well, this is the experimental setup, but for the absorption measure setup. Then in this experiment, they put that the absorption of toluene. This absorption of toluene was effected on a bench scale biofilter, and this biofilter was filled up with compost-based pellets. For this experiment, they chose medium-sized pellets, and they say that the pellets were weighted with an aqueous solution. This aqueous solution contained 2 grams of this compound to eliminate any microbial activity. Then, before each test, the inlet concentrations of toluene was set and measured at the desired value. The desired value were the inlet concentration of toluene from 0 to 3.1 grams per cubic meter, and the empty bed residence time was 65 seconds. Where this is like the diagram of experimental setup for absorption test. Here we have, as we seen before, the air compressor had an air flow mass rate with mass flow controller. This flow is divided into 2. The 2 sections has mass flow controllers. Here we have also a toluene saturation. Then the 2 lines of the mass flow going together and pass by the inlet pass line, that this was the concentrations of the desired value. Then we have the absorption bench scale unit, and all this was measured by hydrocarbon analyzer. Well, in the parts of results and discussions, they first of all choose or discuss the effect of nitrogen. They say that the 3 plus represent 2 or 3 toluene oxidation degradation zones depending on the nitrogen concentration range, that it was to 0 to 2.5 grams of nitrogen.
Next, I explain impact of granulometry in the N limitation and N optimum zones shown in figure 3 with this. The performance increased and decreasing pellet size. This figure shows nitrogen concentration and elimination capacity of three types of pellets: small, medium, and large. By assuming these pellets are spherical, can be defined that this equation, these parameters takes into consideration both the mean pellet diameter, the bed porosity, and the overall surface area of the pellets. We shown this table with values for each granulometry, parameters describing the fluid flow and transfer phenomena for three types of pellets, with specific surface area, particles Reynolds, and dispersion coefficients when these are the equation for these parameters and three types of pellets. In this figure present the increase of the maximum spherical performance with specific surface area in this part and maximum elimination capacity. The specific surface area constitutes a limitation to the biodegradation process. This process was made under experimental conditions. The biofilm densification was a visible progressive phenomenon which led to, number one, the extension of the particle radius, number two, the decrease of the overall specific surface of particles, and number three, the reduction of the interparticle volume with epsilon. And finally, this figure represents the pressure drop evolution in the three biofilters, small, medium, and large, and that's all.
Well, now we have this in figure 7, time against pressure drop in the three pellet sizes, small, medium, and large. As we can see, from day 20 to day 30, there is a big increment in this time, because from day 0 to day 20, the pressure drop remained negligible during almost 15 days. Then it began to increase rapidly. What does it mean? It means that the smaller the pellet size, the higher the pressure drop values. And it also means that it's important the available sites enhance the formation of biomass, which is the product that we are concerning. And this was in the medium and contribute to bed clogging, which is a phenomenon that we are interested in. And then there exist some characteristics that are needed in this process. These characteristics include these three. The first one is the particles arrangement. We cannot just say it's okay like that. No, we need to have some arrangement. And then we have the area available for exchanges. We need some surface for this to happen. And finally, gases flow regime. These are directly related to the pellet granulometric parameters, which was something that my partners explained to you before, but they also govern the transport phenomena within the bed. The limitations associated with different pellets are related to the transfer mechanisms that occur in various porous media. These transfer mechanisms are several, but mostly we have three types of mass transfer. And then there is something very important in this, the reaction aspects. The reaction aspects are the ones that permit the reaction to happen. So the degradation reactor for toluene has been evaluated in three biofilters, as we always said in the presentation: small, medium, and large. This is the main reaction, where the last term of the reaction represents the general biomass composition. And then with this and the plots that we have shown to you before, for each biofilter are aligned. which shows that a proportionality ratio exists between toluene elimination capacity and CO2 production. So it was possible to determine linear equations for each biofilter according to the last square meter. And then the values of the slopes are in the same order, which is an agreement with the parallelism of the curves. Next, we are seeing that the regardless microbial behavior, the quantity of CO2 generated for a given amount of toluene removed was the same in the three bioreactors. So it doesn't matter the size, small, medium, and large. It's the same amount. And then the biodegradation is an exothermic biooxidation reaction. This is very important because it determined some characteristics related to the thermodynamics of the reaction. And then the plots of each series of temperature changes seem to be aligned, which proves the next two statements, which are very important. The first one is that the temperature variation were effectively, and the second one is that they were correlated to the quantity of toluene removed. This had a proportion. And next, with the method, we obtain three balances. These three balances represent the energy transferred in the three biofilters. However, the biofilter small and large have the same reaction. It's just biofilter medium, which has a very insignificant difference. So with these equations, we can see that the slopes of these equations are the exothermicity criteria, which was something that I was saying to you according to the thermodynamics, and then this represents the heat release during the biooxidation. Finally, the three exothermicity criteria are similar, which confirms the fact that the biodegradation reaction mechanisms were essentially equivalent for the three pellet sizes, no matter if it was small, medium, or large. And then the intrinsic degrading microbial activity was independent from the particle characteristics, as the bioreaction parameters remain similar in S, M, and large. With this, we had, the authors gave us a conclusion, a very significant conclusion. This was that the limiting factor for the biodegradation process was physical in character, not biological, as it was supposed.
Well, in the next part of the article, talk about the study of the absorption. Well, what is the aim of do this study? Well, to evaluate the quantity of toluene absorbed on the compost-based pellets. How can do this? We can plot the breakthrough curves of several inlet concentration of the toluene. Well, to make this plot, we need this equation. This time is also related to quantity of toluene absorbed on the bed of the equilibrium as follows in the next equation, where T is the time, L is the height of the bed, B is in interfacial area velocity, and epsilon is the porosity of the wet medium, which is a constant, and the value of this constant is 0.53. Well, quantities of the toluene absorbed are calculated from the next equation. The Q is the state for the airflow rate, V is the bed volume, and rho is the density of the pellet. This equation is how as we can plot the absorption. In the next step, in this study was to model the experimental data with Langmuir and Freundlich models. In the first one, we show the Langmuir isotherm, and this is the equation for this kind of isotherm. And in the second equation is the Freundlich isotherm. And in both of these equations, K1 is the constant of Langmuir, and K2 is the constant of Larum. These constants are different. They have different values, and Kf and N are parameters of Friendlich model only. Well, for this case, in the specific case of this article, the equation provides the following isotherm parameters, in which Langmuir isotherm, the value of the K1 is 344.8, and for K2 is 16.7 grams over cubic meters. And friendly isotherm, the value of Kf is 19.4 and N is 0.92. Well, as a conclusion, the results of the article present in the paper deal with biodegradation of toluene by biofiltration was the first. Our first objective was a study of the influence of filter media pellet size on the biodegradation process. Thus, the elimination capacity increased as pellet size was decreased or as a specific surface area was increased. The further objective of the study and second was the determination of the absorption isotherm from toluene on the compost-based bed. Well, this is the bibliography that we and the name of the article is the author is Delhoin and Bibiu and Hates, and the article was made in 2002.